Good morning, good day to you. Here we go, guys. Our first lesson of distance learning. I decided to go with this is technically chapter 5. It's all about segments that are in triangles. So you want to grab out the note sheet that looks like the computer screen right here. Our first lesson is perpendicular bisectors. It is one of the segments that happen in a triangle that we will go over today. It's kind of a confusing chapter. We will try to make the most of it. And again, no stress as always, right, guys? It's just math and we will get through it together. So take out this note sheet and then we can get started here. Okay. One more second, folks. Sorry. All right. Okay, so we're going to learn about two segments that occur in triangles. The first one, like I said, is perpendicular bisectors, and then the other one is angle bisectors. So after today, you will be able to find different angles and segment lengths in triangles using these properties. Okay, so here we go. We're going to read this little paragraph over here together. So a perpendicular bisector. If a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So there are kind of a few things happening here. So let's break this apart together. Perpendicular, you should be thinking a right angle, right? So kind of always that box, right? That's how we know things are perpendicular because they create right angles, okay? Bisector we know means to cut into two equal pieces, so we split it in half. So again, here's a segment. It's perpendicular to this bottom side because of that box, and we know it's bisecting AB because of those tick marks, okay? So now when this happens, any point that falls on this line here on the perpendicular bisector, it's equidistant, meaning it's equal distant from A and B. So it doesn't matter if it's up here at C or any point along this line, it would be the same distance away from A to B. Okay? So now this is kind of symbolically how they're saying this thing over here. If CD is perpendicular to AB, okay, we have the right angle, and AD is congruent to DB, meaning it's being cut in half, then this segment here, AC, is congruent to CB. Because any point that falls on this line is the same distance away from A to B. Okay, so this is probably what you want to jot down in your notes. I think it's blank there for you. And then remember, the converse is just when you flip it, right? So now if we know that AC is congruent to CB, then we can say CD is perpendicular to AB and AD is congruent to DB. So in this chapter, there's kind of like a lot of things you sort of just need to memorize, just because that's all it is. It's just like memorizing these properties. But kind of like a good rule of thumb is if they look congruent, they probably are. So when we find the value of x, if they look like they're both the same, they probably are. So it's kind of a good rule of thumb. So let's try a few examples. So the first one that you have in your notes, it says find the value of x. So again, we do have that perpendicular bisector happening, right? Here's my right angle, so it's perpendicular, and it's cutting that segment in half because of the tick marks. So now I know that this point here is equidistant to those 2 points. So long story short, right, just get to the point, Miss Bundy. We know that this guy is equal to this guy. So here we go. 7x plus 24 is equal to 13x minus 48. Okay, what do we want to move first? You move the 7x over, so 24 equals 6x minus 48. Add over the 48 and we get 72 equals 6x. Divide out x equals 12. Okay, let's do another one. So now this is kind of representing the converse. So this time we are told that these two sides are the same, which would mean what? Which would mean that this would be a right angle and it's cutting that side in half. So again, long story short, this guy is equal to this guy. Do they look like they're congruent? Yeah, I mean, just kind of eyeballing it, they do. So if you had no idea and you were taking a test, set them equal to each other and see what you get. All right, so if we move our x over, we'll get 8x minus 3 equals 13. Add the 3, 8x equals 16, x equals 2. Okay, perpendicular bisector. Okay, there is kind of a lot happening here in this picture, or on this slide, this part of your notes, whatever you want to say. So, a triangle actually has 3 different perpendicular bisectors, right? Because there's 3 sides, right, to a triangle. So we know that each side could be cut perpendicularly, meaning that there's 3 perpendicular bisectors. So, okay, here we go. The perpendicular bisectors of the sides of a triangle intersect at a point called the circumcenter. So that would be right here. So here are all my perpendicular bisectors of that triangle, and they all come together at one point called the circumcenter. The circumcenter is always equidistant from the vertices of a triangle. So point P is the same distance away from all of the corners of your triangle. So what does that mean? That means that this, let's see, how many tick marks do we need? 4. So 1, 2, 3. This guy, AP, is the same as BP, which is the same as PC, because it's the same distance away. Okay, now we're going to use this picture to answer some questions down here. It says list the perpendicular bisectors. So there is a lot of segments, right, happening here. Your key word there's perpendicular. So you're looking for those little boxes, right? Because we know perpendicular means we get right angles. So our perpendicular bisectors would be segment DP, segment PE, and segment PF. Name the circumcenter. Well, we already said that was what, folks? P. Now it says list all congruent segments. So there is a lot, right? There's a lot happening here. So we're just going to play the matching game. Okay? So AD has 1 tick mark. So that I'm looking for my other tick mark, which is DB. And just remember that perpendicular bisector cuts each side in half, right? It bisects it. So then think about this half has to be the same as this half. Just like AF has to be the same as FC, right? Because we're cutting each side in half. BE is the same as EC. And then this last little nugget of information right here, that the circumcenter is equidistant from the vertices of your triangle. So that means all 3 of those segments are the same. So they gave us AP. And then we know another one would be PB. And our last one, PC. Guys, I realize there's a lot going on here. I realize that I'm talking to no one, so I have no idea if we're understanding this. And I am sorry, right? This is not an ideal situation. But if we need to take more time on it when I see you next, we will. So don't freak out. Just make sure you take your notes. We'll be okay. Okay. Okay, here we go. So we are given that Z is the circumcenter of triangle TUV, and we're looking for each missing measure. So sometimes it's easier to just not even worry about what you're trying to find and then just label your picture. Sometimes it's easier to see what you're trying to find so you don't do a bunch of extra work. There's just kind of like a lot of options here. I kind of personally like to just look at my picture and label everything I can and then see what I'm missing afterwards. I think that's the easiest route to go. Because then we can talk about why they are the way they are, right? So since it's the circumcenter, we know that it's formed by perpendicular bisectors. So all these little sides down here would create right angles. And then what else do we know, kids? We would know that Z, that's our circumcenter, is equidistant to all of the corners of our triangle. So that would mean since ZV is 21, TZ is 21, and ZU is 21. Okay, now remember, our sides are being bisected, so they're being cut in half, right? So if XU is 19, then TX is 19. And if this whole side is 34, I can split it in half to get VY, so that would be what, 17 and 17? So once you fill out this picture, it's kind of manageable, right? Let's see what we can fill in, and then we might have to work our picture a little bit differently for the other missing pieces. So TU, 19 plus 19, right? Would give us 38. VY, where are you? Okay, right here. 17. UZ, we said is 21. WV. Ooh, we don't have WV. However, folks, if we look here, we have a right triangle, right? And then how do you find a missing side of a right triangle? You can use the Pythagorean theorem. So we could do 15 squared plus x squared equals 21 squared, since this is our hypotenuse. And now we crunch out these numbers. 15 squared, I know, is 225. X squared, I do not remember what 21 squared is. 441. Subtract over our 225. X squared equals 216. Take the square root. X equals 14 point, well, approximate to 1 decimal point, 14.7. And then our last one, TV. Oh, bless, look at this, you guys. We just said this is 14.7. To get T to V, we just double it, because I know that this also has to be 14.7. That's not so bad. So 14.7 times 2 gives us 29.4. Perfect. Okay. Good job, I hope. Flip the page. Changing it up to angle bisectors, folks. So kind of a similar thing. Let's read this little nugget of information. It says if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. Okay, so let's break it apart. Here's our angle, right? Each corner of your triangle forms an angle, right? And if I bisect it, meaning we're cutting that angle in half, so then this little half over here is the same as this half over here, then any point that falls on AD is the same distance away from the sides of that angle, okay? So if we read our symbols over here, if AD bisects angle BAC, then ray AB is perpendicular to BD, and AC is perpendicular to CD, then BD is congruent to DC. Okay, then the converse is just the opposite. If we know BD is congruent to CD and ray AB is perpendicular to BD and ray AC is perpendicular to CD, then AD cuts angle BAC in half. Sometimes I think when we read these, we get a lot more confused in what's actually happening. what I want you to take away from all this mumbo jumbo is if you have an angle bisector, any point that falls on that angle bisector is the same distance away from the sides of your triangle. It will make more sense when you put some math with it, but just jot down what's in bold here, okay? Okay, we are asked to find the value of x. So if we look here, I know it's an angle bisector, right? Because my angle is being cut in half. Then we said any point that falls on that angle bisector is the same distance away from the sides of the triangle. So long story short, this guy is congruent to this guy. So 9x minus 5 is congruent to 5x plus 30. Bring over our x's to the left side. So we have 5x minus 5 equals 30. 5x equals 35. X equals 7. Woohoo! Okay, now we're looking at the converse. This time, we are told this point here is the same distance away from the sides of our angle, right? Because that's what those tick marks mean. So now since we know that, we know it's cutting our angle in half, meaning this guy is congruent to this guy. So we can simply just put them equal to each other. Throwing our x's to the left side, so I get 3x minus 41 equals negative 11. Add 41 over, which we get 30. X equals 10. Okay, now just like we had 3 perpendicular bisectors to a triangle, we also have 3 angle bisectors to a triangle. So it says the angle bisectors of the angles of a triangle intersect at a point called the incenter. So where all 3 of those angle bisectors touch is called the incenter. The incenter is always equidistant from the sides of a triangle. So let's star this little guy. That's a pretty good piece of info. So what does that mean? That means, so here's our incenter P. Now it's the same distance away from the sides of our triangle. So then DP is congruent to PE, which is congruent to PF. And just like before, we're gonna use this diagram to label the following information. List the angle bisectors. So our angle bisector, so what's cutting our corners in half? Well, our first one would be BP. Our second one would be AP. And our last one would be PC. Name the incenter, that is P. List all congruent segments. So remember, our pictures were kind of given like parts of our triangle like this. So FC right here, you guys, is really the same as EC. So you can put 2 little tick marks there. So FC is congruent to EC. BE, 1, 2, 3, is congruent to DB. AD, 1, 2, 3, 4, is congruent to AF. And then now we're going to give our sides to our sides of our triangle. So DP is congruent to PE, which is congruent to PF. How are we doing? I wish we were together. Okay. This is our last one. Why do I feel like there's more? Kids, is this it? Where's all my paperwork? Okay. Do you have this one? Do we still have one left to do together? Where is it in my notes? Oh, it's on the bottom. Oh, you guys, I am losing it. I am so sorry. It's here. It's on the bottom of my sheet. Okay, last example for notes. Here we go. It says if P is the incenter of triangle JKL, find each missing measure. So again, I think instead of focusing on what we're trying to find, let's label what we can and then we'll go from there. So if we review, P is the same distance away from all of the sides. So if this is 8, so is NP and so is PO. And then if we work our way around our triangle, OK is 17. So then I know that NK is 17. And that may be all we can do right now. Okay, let's see what we can fill in. NP, we labeled as 8. NK, we labeled as 17. PK, oh, we don't know it, but remember guys, these are all little right triangles in there, so we can just do the Pythagorean theorem. This time our hypotenuse is x, so 8 squared plus 17 squared equals x squared. 8 squared we know is 64. 17 squared, I don't remember off the top of my head, is 289 equals x squared. Add those together, we get 353. And then we simply take the square root. 18 point, approximately 18 point, we'll round to 8. And then LO we're looking for, so again, we don't know it, and this is a little right triangle. So we can do the Pythagorean theorem here. X squared plus 8 squared equals 13 squared. 8 squared, 64. 13 squared is 169. X squared equals, that would be what, guys? 105. We take the square root. Oops, wrong button here. We get 10.2-ish. Okay. I'm sorry that this got long. And I'm sorry it's probably confusing. And I'm sorry we're not together. But thank you for watching. If you've made it this far, I appreciate you more than you know. Have a super rest of your day, and I will see you next time.